The story of research is the story of us. It begins not in a gleaming laboratory or a dusty library, but with a simple, powerful impulse. It's the feeling a child gets when they look up at the night sky for the first time. They see a tapestry of glittering lights scattered across an infinite darkness. They don't know what they are, these points of light. They don't have names for them, but they have questions. What are they? How far away are they? Are we alone? This instinct to question, to wonder, to seek understanding, this is the seed of all research. It's a fundamental part of what it means to be human, an engine of curiosity that has driven our species since we first walked the earth. This innate drive wasn't reserved for special people in special places. It was woven into the fabric of everyday existence. Imagine an early human ancestor watching a plant. They notice it wilts without water and thrives in the sun. They see which berries are safe to eat and which are not by observing the animals around them. This is research in its purest form. It is observation, hypothesis, and experimentation, all driven by the need to survive and the desire to understand the world. It was a direct conversation with nature, a dialogue between humanity and the cosmos, where every discovery had immediate meaning and purpose for the community. Before we had formal methods, we had our senses. Before we had peer-reviewed journals, we had stories passed down through generations. A hunter-gatherer society knew the migratory patterns of animals, not because they read it in a book, but because their survival depended on it. They learned these complex ecological rhythms through careful, sustained observation. This knowledge was a shared treasure, a collective library of experience that ensured the group's continuation. Research wasn't a separate activity, it was a way of life, a continuous process of learning and adapting to the world as it presented itself to you. Think about it. The first person to strike two stones together to create a spark wasn't following a research grant proposal. They were likely driven by cold, by darkness, by a simple idea. What if? That what if is the most powerful question in the universe. It's the launchpad for every great leap forward. This initial form of research was deeply personal, intimate, and connected to the immediate challenges and wonders of life. It was about solving a problem right in front of you or satisfying a profound curiosity about the world you inhabit. It was a dance between necessity and awe, a journey that started with a single curious thought. As societies grew, so did our capacity for abstract thought. In the cradle of civilization, from ancient Greece to Mesopotamia, India, and China, thinkers emerged who had the luxury to ask questions that went beyond immediate survival. They could look at the cosmos and see not just a source of omens, but a grand, orderly system. Consider Thales of Miletus, one of the first we know of to suggest that the universe could be understood without resorting to myths about the gods. He proposed that natural phenomena had natural explanations. He believed all things came from water. He was wrong, of course, but the revolutionary part wasn't the answer. It was the belief that an answer could be found through reason. These ancient philosophers were driven by a profound love of knowledge itself. Aristotle, for instance, was a walking encyclopedia of the ancient world. He didn't just ponder the heavens, he got his hands dirty. He dissected animals to understand their anatomy, he categorized plants, he studied weather patterns, and he analyzed human societies. For him, research was a comprehensive project to understand everything. He wasn't trying to get tenure at a university or secure funding. He was simply trying to satisfy an insatiable curiosity about the nature of reality. His work became a foundation for Western science for nearly 2,000 years, a testament to the power of one person's relentless questioning. This spirit wasn't confined to Greece. In ancient India, mathematicians like Aryabhata calculated the value of pi with remarkable accuracy and proposed a heliocentric model of the solar system centuries before Copernicus. In the Islamic Golden Age, scholars like Ibn al-Haytham pioneered the scientific method itself, emphasizing controlled experiments and empirical evidence, especially in his study of optics. These were not isolated geniuses. They were part of vibrant intellectual cultures where knowledge was pursued for its own sake, for the sheer joy of discovery and the desire to comprehend the universe's magnificent design. They were explorers of ideas, charting the vast, unseen territories of the mind. What united these diverse thinkers across different cultures and eras was their approach. Research was a philosophical pursuit, a way to live a more examined life. It was deeply intertwined with ethics, art, and governance. To understand the stars was to understand our place in the cosmos. To understand biology was to understand the essence of life. There was no sharp dividing line between science and humanities. It was all part of one grand quest for wisdom. Their legacy reminds us that before research became a profession, it was a vocation, a calling to engage with the biggest questions existence has to offer. Long before the formal halls of academia were constructed, research was a communal and practical endeavor. It lived in the hands of the craftsperson, the mind of the healer, and the memory of the village elder. Consider the medieval blacksmith, a master of metallurgy. They didn't learn their craft from a textbook on material science. They learned through generations of trial and error, a hands-on research program passed from master to apprentice. Each swing of the hammer was an experiment. They knew precisely how to heat, bend, and quench steel to create a strong, flexible sword or a durable plow. This knowledge was hard-won, practical, and essential to the community's survival and prosperity. In the same way, traditional healers and herbalists were dedicated researchers. They held a vast living database of botanical knowledge. They knew which leaves could soothe a fever, which roots could ease pain, and which flowers were poison. This wisdom wasn't discovered in a single breakthrough. It was accumulated over centuries of careful observation, experimentation, and oral tradition. A healer would walk the same forest paths day after day, noting how plants changed with the seasons, how they affected the body, and how they could be prepared. This was a form of clinical research, deeply embedded in the health and well-being of their people, a science of place and relationship. This model of embedded research extended to every facet of life. Farmers were experimental agronomists, constantly refining their techniques for crop rotation, irrigation, and pest control to coax more food from the land. Sailors and navigators were astronomers and oceanographers, reading the stars, tides, and winds to chart new courses across unknown waters. Their ships were floating laboratories, and every voyage was a research expedition. The knowledge they gathered wasn't published in a journal. It was etched onto maps, recorded in logbooks, and shared in the taverns of port cities, becoming the common property of all who dared to venture out to sea. What defined this era of research was its direct connection to human needs and its collaborative nature. Knowledge wasn't hoarded, it was shared because a community is only as strong as its collective wisdom. The master craftsperson taught their apprentice, the healer shared their remedies, and the sailor passed on their charts. Innovation happened organically, driven by practical problems and shared solutions. It reminds us that research doesn't require a specialized building or an official title. It requires a problem to solve, a community to serve, and the freedom to learn by doing. It was a system built on trust, tradition, and the shared goal of a better life. The nature of research began a slow, profound transformation with the birth of a new kind of institution, the university. Beginning in the medieval period, places like Bologna, Paris, and Oxford became centers where scholars could gather, not just to preserve ancient knowledge, but to debate and expand upon it. For the first time, learning became formalized. A curriculum was established, degrees were granted. Research was shifting from a dispersed practical activity into a more concentrated intellectual pursuit. The ivory tower was being built, brick by brick, creating a space set apart from the everyday world, dedicated solely to the life of the mind. Then came the scientific revolution, and with it, another monumental shift. Thinkers like Francis Bacon championed a new, systematic approach to discovery, the scientific method. This wasn't just about thinking, it was about testing. The formation of scientific societies like the Royal Society of London in 1660 was a game changer. Their motto, nullius in verba, or take nobody's word for it, was a declaration of independence for empirical evidence. These societies created a platform for researchers to share their findings, critique each other's work through peer review, and publish their results. This process made science a collaborative, self-correcting enterprise on a scale never before seen. As science and industry became more intertwined in the 19th and 20th centuries, research became even more institutionalized. Large, dedicated laboratories emerged, funded by corporations and governments. Think of Thomas Edison's lab at Menlo Park, an invention factory designed to churn out innovations. Research was no longer just the domain of the lone genius or the curious aristocrat. It was becoming a profession, a job you could be trained for. This professionalization brought immense resources to bear on complex problems, leading to an explosion of discovery in fields from physics and chemistry to medicine and engineering. The search for knowledge was now an organized, well-funded, and powerful engine of progress. This new structure had undeniable benefits. It provided a stable framework for inquiry, allowing for long-term projects that would have been impossible for individuals to undertake. It created standards for evidence and verification, making knowledge more reliable. Universities and labs became crucibles where brilliant minds could be forged, trained in the rigorous methods of their disciplines. They opened the doors of discovery to a wider range of people, not just the independently wealthy. The structure that had been built, the ivory tower, the scientific society, the industrial lab, was incredibly successful at generating new knowledge. But this success came at a cost, creating new pressures and a different kind of distance from the world. The institutionalization of research unleashed a torrent of progress that honestly reshaped our world. In just a few centuries, we went from believing Earth was the center of the universe to sending probes to its outer edges. We eradicated diseases like smallpox, which had plagued humanity for millennia. We unlocked the secrets of the atom, harnessed electricity, and created a global communications network that connects billions of people in an instant. This incredible acceleration was a direct result of the structured, professionalized, and well-funded approach to discovery. It offered a reliable pathway for turning ideas into testable hypotheses, and then into technologies and medicines that improved and saved countless lives. One of the greatest gains was the democratization of discovery. While still imperfect, the university system and government-funded research opened doors for people from all walks of life. You no longer had to be a person of independent means, like Charles Darwin, to afford to be a scientist. Scholarships, grants, and academic positions created a career path. This broadening of access brought new perspectives, new talents, and new ideas into the scientific enterprise. It meant that a farmer's child with a brilliant mind for mathematics, or a factory worker's daughter with a passion for chemistry, could contribute to the expansion of human knowledge. Progress was no longer just for the privileged few. However, this same structure that fueled progress also began to create a new kind of distance. Research, once a part of daily life, became something that happened over there, in a lab or a university, done by specialists speaking a language few could understand. The direct connection between the blacksmith's forge and the community's needs was replaced by a more abstract pursuit. The wonder that drove Aristotle to classify every living thing he could find was sometimes overshadowed by the need to secure the next grant. The focus shifted from the grand philosophical questions to smaller, more manageable problems that could yield publishable results in a reasonable time frame. This separation carried a profound loss. As research became more specialized, the holistic view of the ancient philosophers began to fracture. A physicist might not speak the same language as a biologist, who in turn might not understand the work of a sociologist. This hyper-specialization was incredibly effective at solving narrow problems, but it made it harder to see the big picture, to connect the dots across different fields of knowledge. The joy of pure, unbridled curiosity, the simple act of wondering about the world, could get lost amid the deadlines, the administrative tasks, and the intense pressure to produce. The system designed to foster discovery was, in some ways, beginning to stifle the very spirit that gave it birth. As research matured into a global profession, a new and powerful dynamic took hold: competition. Universities and labs began to compete for the best minds, the biggest grants, and the most prestigious awards. This competitive environment can be a powerful motivator, pushing scientists to work faster and smarter, to race toward a breakthrough before a rival group does. The race to map the human genome, for example, spurred incredible innovation. But this constant competition also transforms the collaborative spirit of science into a zero-sum game. Instead of sharing information freely, researchers might withhold data, fearing they'll be scooped by another team. The focus can shift from getting the right answer to getting the answer first. This intense competition is fueled by the modern system of research funding. Most scientific research today depends on securing grants from government agencies or private foundations. The process is incredibly demanding. Scientists spend a huge portion of their time writing detailed proposals, essentially begging for the resources to do their work. Only a small fraction of these proposals get funded. This creates a bottleneck where the direction of science is often dictated not by pure curiosity, but by what review panels deem to be a safe bet. It encourages incremental, low-risk research over bold, paradigm-shifting ideas that might be too radical to get funded. This leads directly to the mantra that governs academic life: publish or perish. A researcher's career, their chance for tenure, and their ability to secure future grants all depend on a steady stream of publications in high-impact journals. This pressure fundamentally changes the goal of research. It's no longer just about understanding the universe, it's about producing a quantifiable output, a paper. This can lead to what's called salami slicing, where a single study is carved up into the thinnest possible publishable units to maximize the number of papers. The pursuit of knowledge is replaced by the pursuit of lines on a curriculum vitae. The result is a system that often prioritizes quantity over quality. It can discourage long-term difficult studies that might not yield results for years. It can tempt researchers to chase trendy topics instead of following their own unique curiosity. And in the worst cases, the immense pressure to publish can lead to sloppy science or even outright fraud. The modern crucible of research, while capable of forging brilliant discoveries, also risks burning out the very people who fuel it. It creates a culture of anxiety and pressure that stands in stark contrast to the joyful, contemplative wonder that first inspired us to look at the stars. In the modern research ecosystem, we have become obsessed with measurement. We measure everything. A scientist's worth is often reduced to a set of numbers: their H-index, their citation count, the impact factor of the journals they publish in. Universities are ranked, departments are evaluated, and grants are awarded based on these quantitative metrics. On the surface, this seems objective and fair. It's an attempt to bring order and meritocracy to the chaotic process of discovery. But when we try to quantify something as intangible as curiosity, or as complex as a scientific breakthrough, we risk losing the essence of what we are trying to measure. This relentless quantification takes a heavy human toll. The pressure to maintain these metrics creates a perpetual state of anxiety for many researchers, especially those early in their careers. Graduate students and postdoctoral fellows often face long hours, low pay, and an uncertain future, all while navigating the immense intellectual and emotional challenges of their work. The joy of a small discovery can be quickly eclipsed by the worry of whether it's significant enough to be published in a top-tier journal. This culture can lead to burnout, disillusionment, and a serious mental health crisis within the academic community. We are asking our brightest minds to explore the frontiers of knowledge, but we are placing them in an environment that can be detrimental to their own well-being. Furthermore, this focus on metrics can distort the scientific process itself. It creates a powerful incentive for positive results, as studies that show a strong, clear effect are more likely to be published. This leads to a file drawer problem, where countless studies with null or negative results, which are just as important for science, are never published. They sit in a file drawer, unseen by the rest of the scientific community. This publication bias skews our understanding of the truth, as other researchers may waste time and resources repeating experiments that have already been shown not to work. The obsession with a successful outcome can ironically make science as a whole less successful. We must ask ourselves a difficult question: does a high citation count truly measure a contribution to human understanding? Albert Einstein's 1905 papers, which revolutionized physics, were not initially highly cited. Gregor Mendel's groundbreaking work on genetics was ignored for decades. The most transformative ideas are often the ones that are too far ahead of their time to be immediately recognized or quantified. By focusing so intensely on the tally, we risk creating a system that is excellent at rewarding conformity and incremental progress, but poor at nurturing the kind of radical, creative thinking that leads to true revolutions in our understanding of the cosmos. Just when it seems the professionalization of research has pushed it out of reach for most people, a new movement is pulling it back. We are in the midst of a new renaissance powered by the most democratic tools ever created: the internet and the personal computer. This is the era of citizen science. You no longer need a doctorate or access to a university lab to contribute to real, meaningful research. All you need is a connection and a spark of that old, familiar curiosity. Projects like Zooniverse invite anyone to help classify galaxies, identify animals in camera trap photos, or transcribe historical documents. This isn't just busy work. Citizen scientists are making discoveries that would be impossible for small research teams to accomplish on their own. The human brain, especially its pattern recognition ability, is still more powerful than any algorithm for certain tasks. Think of the Galaxy Zoo project, where hundreds of thousands of volunteers classified the shapes of millions of galaxies. In the process, they discovered an entirely new type of galaxy, the green pea, which professional astronomers had overlooked. This is a powerful demonstration that the spirit of discovery belongs to everyone. It democratizes the scientific process, returning it to its roots as a collective human endeavor. The digital frontier is also transforming how professional researchers work, offering a potential antidote to the pressures of the old system. The rise of open-access journals and preprint servers like Arxiv allows scientists to share their results instantly and freely with the entire world, bypassing the slow and often biased traditional publishing system. Open-source software and hardware are making the tools of research cheaper and more accessible. Collaborative platforms allow scientists from opposite ends of the globe to work together on the same dataset in real time. These tools are breaking down the walls between institutions and fostering a more open, transparent, and collaborative scientific culture. This new landscape offers us a chance to build a better system. Imagine a future where research data is openly available to anyone who wants to analyze it, where findings are discussed and critiqued in a global, ongoing conversation. Imagine a world where professional scientists and passionate amateurs work side by side, each contributing their unique skills to solve the great challenges of our time, from climate change to curing disease. The digital age provides the tools to make this a reality. It allows us to connect the focused power of professional research with the distributed passion and wisdom of the crowd, creating a scientific enterprise that is more robust, more inclusive, and more powerful than ever before. Our journey through the story of research has brought us full circle. We began with the pure, innate wonder of a human looking at the sky and asking why. We saw how that impulse was channeled by ancient philosophers and put to practical use by communities. We watched as it was structured and professionalized, leading to unprecedented progress but also creating immense pressure and a sense of disconnection. Now, we stand at a crossroads, with the opportunity to forge a future for research that blends the best of both worlds, the rigor of the modern method with the wisdom of the ancient spirit. To build this future, we must actively work to bring curiosity back to the center of the scientific enterprise. This means changing the incentive structures in academia. We need to find ways to reward not just publication counts, but also creativity, collaboration, and the courage to tackle risky long-term questions. We must support research that crosses disciplinary boundaries, reconnecting the fractured fields of knowledge to address complex, real-world problems. It means creating a culture that values the well-being of its researchers as much as it values their results, recognizing that a healthy, curious mind is the most valuable scientific instrument of all. We must also continue to break down the walls between the ivory tower and the rest of society. The rise of citizen science is not just a novelty. It is a fundamental shift toward a more participatory and democratic model of discovery. We should integrate these approaches into our education systems, teaching children not just what we know, but how we know it, and inviting them to be active participants in the process of discovery from a young age. By making research a part of everyday life again, in our schools, our communities, our homes, we rekindle that direct personal connection to the cosmos. Ultimately, the goal is to create a more holistic, more human, and more meaningful approach to understanding our universe. It's about combining the analytical power of our modern tools with the contemplative wonder of our ancestors. It's about recognizing that every human being is born a scientist, endowed with the capacity for awe and a desire to know. The cosmos is waiting. Its mysteries are as vast and as deep as ever. The future of research, and perhaps our future as a species, depends on our ability to reclaim that foundational spark of wonder and to build a global community dedicated to the shared, joyful, and never-ending quest for knowledge.